Alright guys, today's goal, the learner will understand how to completely factor a polynomial and learn factor by grouping. So factor the expression. So I look. What do these two things have in common? They have the x minus 2 there. So if I pull out the x minus 2, so those are gone. What am I left with here? X. What am I left with there? It looks like nothing, but that's the same thing as saying 1. So plus 1. So that's factored. We're going over this because this introduces the grouping. You'll see in a couple examples here. So press pause and try this last one here. So what do they have in common? The x plus 4, so pull that out. What's left over? 2x minus 3. Okay, so good to go. Now let's learn how we get it to that point. So factor the polynomial by grouping. So they're all the same variable, so you group them. Put the first two together and the last two together. It's very critical that that's a plus in there always. Okay? So what do these two things have in common? Well, they have a squared in common. So what's a to the third divided by a squared? A. 3a squared divided by a squared? 3. What do the a and the 3 have in common? So what does the a and the 3 have in common? Nothing. So what does that mean you factor out? A 1. And it doesn't change anything. See how now it looks like the previous problems? So they have this a plus 3 in common. Factor it out. What are you left with? A squared plus 1. A plus 3 can't be factored. A squared plus 1. I see that squared and I think it can be factored. But let's see. Is there anything that multiplies to positive 1 and adds to 0? No. So you are complete. So let's look at this one. Well, what do the first two have in common? Nothing. So you could say a 1. So if I did that, I'd get this. What do the second two have in common? A y. Do I have anything that matches to be able to factor out here? No. So we got to back up. Doesn't mean it can't be done, but we got to back up. So I look at this and I think, let's get things that match. So I see a y squared and a y. So I go y squared plus 2y plus 2x plus yx. See how I put the ones that were just y and then the ones that had the x's together? Now, if we group these, let's see. What do the first two have in common? Y. So you get y plus 2. What do the second two have in common? X. So you get 2 plus y. Well, couldn't we rewrite that? Isn't 2 plus y the same thing as y plus 2? So now you see they have the y plus 2 in common. So factor that out. What are you left with? Y plus x. So there you go. We're starting to get the hang of this. Let's go next page. Okay, factor it completely. What do they have in common? Well, 3 and x. So I factor that out. 3x to the third divided by 3x, x squared. Negative 12x divided by 3x, negative 4. Are we done? Let's see. I have the 3x, and I have x squared minus 4. Is there anything that multiplies negative 4 and adds to 0? Well, remember what we learned. If it adds to 0, they have to be perfect squares. So yeah, isn't 4 a perfect square? So you get x plus 2, x minus 2. Now just like before, if I said this equals 0, this equals 0, you have to set each factor equal to 0. So here, divide by 3, x equals 0. Subtract 2, x equals negative 2. Add 2, x equals 2. So you get all 3, okay? So let's look here. What do they have in common? They have 2y. 2y to the third divided by 2y, y squared. Negative 12y squared divided by 2y, negative 6y. 18y divided by 2y, 9. So what multiplies to 9 and adds negative 6? Negative 3 and negative 3. But I can write that as 2y times y minus 3 squared. Okay? Alright. So here's your guys' homework. Make sure you get these 2 problems done. I will see you tomorrow.